3.0, 4.0, no way to generate the list. JavaScript, of course, is nothing like Java, and you know, it's a lot shorter. But you know, they have this long word, function. So they obviously optimize for function. Here they've done something kind of neat, and that is because they're using a reduce function as higher order programming, and they're passing another function to it, they can do the, instead of pointing, they can do the exponentiation and the addition in the same function. That's a neat trick. But again, notice they have to put the 0 there. It can't figure it out for itself. Perl, in contrast, never mind. Oh, wrong letter. Okay, so much for the live demo. Oh, I know what the problem is. It doesn't like that. Okay, it knows that that's 0. Here's an interesting thing, though. Suppose you're multiplying a list of numbers, and there are none of them. What should that be? Ichi. Right. Suppose you're checking to see if things are ordered. The default is true. The null list is ordered. So Perl 6 is smart this way. Obviously, JavaScript is stupid. And do you have to use return in JavaScript? It's required. Okay. I thought it might be from the example. Do you have to use the parens here? Is return a unary function that's, or is this just superstitious? I don't know. But it makes you wonder when you see an example like this. And again, the math.squirt problem. And we seem to not have a range here either. Now, what about Python? The language we love to love to hate or something. Okay, here's the example. Yeah. The future is here today, is just unevenly distributed. Python does not have the future yet. It must import it. It also must import square root. It's not enough that it say math.square root. It has to say from math import square root. You must use white space. Now, here's a nice thing. They have list comprehensions built in to Python. But that's also a bad thing because it's special syntax. In Perl, we can just use a loop modifier for this, a normal modifier, and it just falls out of the actual syntax. Now, here's a really funny comment. Why didn't they design the language to work like the comment works? Now, Python is not the ugliest language. I don't know which language is. Well, at least they put the verbs at the end, like Japanese. You know. Now, does any language do it shorter than Perl 6? Yeah, hi. Mathematica. Now, is there any language that does it short without cheating? Sure. A variant of APL?
Watashi no name wa Goldilocks. 大きすぎる。小さすぎる。
For many more examples of bad language design, you can look at Rosetta Code. If you want to do that, you can just go to that website, and there are many things to look at. If you go to languages, you can see all the languages that they do. I guess Perl is on the second page. So Perl 6. And it's a lot of fun to write these too. These are all the examples that we already have for Perl 6, and these all run on some version of Perl 6 or another. Slowly, very slowly, but they run. So the one I was showing you was here somewhere. Anyway.
Under A.
Under A. Well, any case. Yeah, average is root mean square. That's where we were, that one. But, yeah. But a lot of these are a lot more fun. For example, spiral matrix. This says to write a spiral matrix that looks like this. Okay, you see how the numbers go around? I don't know if you can see that. And so I decided to do it the fun way. Here's a version that doesn't using turtle graphics. So in Perl 6 here, we've got the directions, and they're all in a row. There are 8 directions. So I'm going to run this for you. What the turtle can do here, so here we have a class turtle. If you know Moose, then this will be kind of familiar to you. It has 2 attributes. And we have a world, and we know what our vector is there for our directions. And we can invert that and get a mapping for debugging. Okay, and do we have debugging off? Okay, so, and we can look around, we can turn left, we can turn right, we can move forward. If we look ahead, we can see if something's ahead of us, and we can lay an egg, which is just a number, and we can show the map. So the first one here, we do this by going in from the outside. This is the usual way to do it. So we go at one row, and then we do 2 rows of one length, and 2 rows one shorter, and 2 rows of one shorter until we get to the middle. And each time we turn, and that works like this. We can also go outward. This one's easier because we don't actually have to count anything. We just look, we turn and we look, and if there's something already there, then we turn back and keep going straight. And as soon as we find an empty spot, we stay turned. So, this does it the other direction. And it doesn't care about whether you start at 0 or not. It knows how to keep track of that. And finally, notice we have 3 different main subroutines here. It's actually using multi-method dispatch to pick which program it's running. This one does what's called the zigzag matrix. Where did we put that? It's on the next page, of course. We go there. Zigzag matrix. This one looks like this instead. 0, 1, 2, 3, 4. So it's going back and forth until it goes the whole length, and then it gets shorter and shorter and shorter. So we can do that one too. Out there. You can see that it is that Rukudo is running about as fast as a turtle, and you can see it garbage collecting. Garbage collect. Garbage collect. Garbage collect. Garbage collect. Garbage collect. See, it's smart. It grows it when it needs to. Yay. Anyway, so Perl 6 is also fun. And there's lots of different, just every kind of algorithm out there, and that's only about half the problems out there that we've solved so far. So if you want to help, you can solve some of the other problems too. Well, English, I don't have to say thank you, but I will say thank you anyway. どうもありがとうございました。I love you guys.